Well, good afternoon, everybody. And I'm saying good afternoon because we are filming after part one of this last series because JP and I have meter schools coming up. So we got Glems and Auburn coming up next 2 weeks. So we're filming these next two ahead of time. So it is actually, usually it's always in the morning, but it's in the afternoon now. So good afternoon. What we're going to be doing today is we got some great, this was a great site for some training opportunities. So we're going to be looking at that 5S meter again. We found some interesting things in there we're going to use for teaching. And, and so you guys know some of this stuff, and I'll explain it as we go along today. You know, I haven't seen this stuff in a long time, and I can't remember everything that we found or saw because we tested so many sites. So I was looking at things, and as I'm watching it, you know, the way we do this is usually, unless it's our schedule is so JP and I'll just kind of go through it and watch it one time and bring everything back into my pea brain again, and then we'll go ahead and do the thing. So as I was looking at this, I saw something that actually goes back to the last one on the part one that we did. And I'll talk all about that here in a minute. It's just funny how stuff connects up and goes full circle. And in this case, it's pretty neat on what Steve talked to us about some stuff last time and drew up on the whiteboard, and then it actually came into fruition in this set of testing that we did today. So you're going to get to see that. So here's where I pray ahead. I'm going to pray ahead to the next one of these we do, so which is kind of odd, but we'll go ahead and start out with a prayer. We're not going to skip that, and then we'll get into it today. So, Father, thank you so much for today. Thank you so much for what you're doing in our company and the things that are going on here. It's pretty exciting, the things that are going on here and the new stuff we're coming up with. And Father, I just want to lift up all the folks here at my company that come alongside me, support me, and are loving brothers and sisters in Christ. And that's what, you know, I can always pray for that. I can pray ahead for that, Lord, as we should always be that way. As this whole thing of looking down our noses or thinking anybody's any better than anybody else is so crazy if you really are honest about it, because we're all the same when we get down to our hearts and our souls and our emotions and our spirits and how we're trying to make it through this life. So, Father, I just thank you so much for today again, and thank you so much for this time we can spend with our Powermetrix Nation family out there. And Father, all of these things I ask and say, according to the will of the one who paid it all, my brother Jesus Christ. Amen. All right, so what we got here? So we got the 2021, so now we're at webinar 23. So we're going to, so today we're doing part two, doing part three right after this, but you won't see it until the 17th. And again, he's got the hook in me now. Please register so I don't have to delete all of these auto replies. So please register, hit that button right below there for the video player. Today, we are going to do a quick review of part one. We're going to do some wire tracing. We haven't done that before. I wanted to do that. We're going to connect up to the meter, test the meter, and then we're going to get a bad registration. And we're going to start that Rolodex going of why did we get a bad registration? You know, what's going on? So, so in part one, you know, like I said, we got up there, we inspected everything. This is a site, it was a church. We had a Padmount transformer. We had where the sanctuary was a 9S, and they had built another building out there, and they fed it with a 5S. So you've got two sets of CTs inside that Padmount. I've got 2 voltages and 2 currents on the 5S, so I've got 2 CTs from my 2 currents in there, and then I've also got 3 of them for the 9S, feeding the 9S. So all the CTs are in there. The connections were a little bit different, so Jonathan just got around the conductors going to that 5S. Wanted to make sure he didn't grab extra stuff. He made some good points about looking at your, you know, the amount of current and voltages and things you got there to maybe see if you grabbed something extra, if suddenly your primary current was up higher than it should be. That was a great point he brought up. But one thing that I haven't talked about before, and guys use this all the time out there, tracing their wires. I've asked JP to put this up here. You're going to notice, and if it's color-coded, obviously it's a whole lot easier. But in this case, these are my 2 CTs right here that are feeding that 5S meter. Okay, and if you notice here, coming out of here, I've got an orange wire coming out of here, and I've got a blue wire coming out of here. Okay, so now as we start moving forward and go into this video, I'm going to stop it and point out, you're going to see that orange and blue wire coming in the bottom of that test switch. So they're coming out of the X1 out of here, and they're going right up into the test switch. So it's coming straight out. We're feeding that secondary current. I got my primary current coming through here. The windings and everything inside this CT produces a secondary current out of these two terminals over here in a ratio of whatever the CT is, in this case 200 to 5. So it's producing a ratio of 200 amps through here, gives me 5 amps out of here. Okay, so this is where I'm getting my current, that orange and that blue, and we'll see them again. All right. So now we'll go over here to the meter, and you can see that Jonathan set up a 7 series on this one. So we've got. So remember, I was saying I hadn't seen these in a while. So when I first looked at this, and I was reviewing this, going over it with JP, and as soon as I saw those, all of my Powermetrix users out there are going to know. I looked at that and I went, whoa, wait a minute, that can't be a 3 series because we've got them stacked, right? I've got it stacked on A and stacked on my neutral right here. I've got my aux power here and my aux power here. On the 7 series, you use the power at the site to power and charge up that battery, and especially if you're going to be doing any kind of load boost or phantom load tests, then you definitely want to have that thing charged up. So here's what he's done is he stacks he's got the black and the white here off of my aux power, which is going to have a black, a white, and a green, right? So I'm right here. I got my black and my white right here. So I just need to make sure I'm right here on my black and my white. And so I took them and I stacked them. I stacked my white on here on my neutral connection, my neutral coming off my voltage cable. And I stacked my black here. I stacked it on the red, which was my A phase voltage on my voltage cable, okay? And that way, if I have those two hooked up, then I'm doing my charging. When I saw that stacked up right there, and I was watching with JP, I went, oh, wait a minute, that can't be a 3. And sure enough, it is a 7 right here, okay? Now, also, as we move forward here a little bit, you notice what we're seeing here, blue and orange. Remember, we talked about that, right? The blue and the orange cables coming from what we saw earlier, coming from inside that Padmount transformer. There's my orange and my blue currents coming right there, okay? So you see the same colors right here and here. Thanks, JP. Jonathan set up a 7 series on this one. So we've got a 7 series set up, and right now he is just connected up, which is when you first show up at the site and he's doing the other connections, it's a good idea. Look what he's done. He's went in, connected up, and just let this thing charge, okay? So it doesn't hurt it any, and you want to make sure it's charged up really well, because you don't know when the last time someone used this, because not everyone, sometimes at utilities, that's my test kit and I'm the only one using it. Somebody else might be using it, so go ahead, and he's been charging it while he's over there making the connections and everything. Then he's going to connect everything else up. But notice he's just here on, he's got his A and his neutral here, so he's connected up. And then he's turned on his aux power right here. You can hear the fan running wide open. And because I'll get that question from guys and they'll say, man, my battery doesn't seem to hold a charge very well at all when I get out there. And I'll say, well, are you charging it? And they say, yeah. And I'll always ask the question, does that fan drive you crazy while you're charging it? And if they say, what fan? Then I know they don't have that aux power button on. So you have to have the aux power button on right here. And when you have it on, that cuts the fan on wide open, and that's giving you your full charge, okay? So it's taking, and all it's doing is charging the 7 series right now. If he turns on the on button, he can also do that, but it's not just charging the test kit now, it's also running the screen and the other stuff. And typically when you turn on the on button, you'll hear the fan drop because now it's turning on the internal thermostats and everything else, right, Jonathan? Okay. I'll get out of his way and let the pro go to work. Okay, so we're ready to make the connections here at the test switch and the meter. So what's the order that you do? Everybody's got a different order, and why? So how do you do it, Jonathan?
I normally do my duct bills first, just simply because when I hook the voltages on there, if I go to open up this shunt with these gloves.
Okay, sorry to stop us here real quick, but remember I was telling you about the orange and the blue here. I just wanted everybody to understand. See, here's where my orange is coming up into here, into the bottom of my shunt over here, okay? And then I've got my blue is coming up in the bottom of my shunt over here. Okay, so just so you guys know, that's where I'm coming in from from my pad mount. I'm coming through here through the my conduit, and there's my orange and my blue coming from the X1s off of my 2 CTs that y'all saw sitting down here. So they're coming, they're feeding here, and they're coming the orange and the blue out of here. So they're maintaining the color coding, which is great. It helps a lot on the tracing. All right.
Or even just the blade, I could knock it off there if
right.
I've got it just clipped on the side. So I like to do the duckbills first. I know Brian does it opposite. He does the voltages and turns them, but that's just, you know, to each their own. It works for him, and duckbills first works for me.
Absolutely.
But I know here that we've got a single phase service, and single phase I'm going to use my red and my yellow duckbill. Now we do have extra test switches here, but you can see there's no wires landed on them.
That's right.
So we've just got an A phase and a B phase.
Right. So for this service, we said it's a single phase service. So notice that he knows, having done enough of them, that he's going to be on A and B. You know, for an open delta, you're going to be on A and C. But in this case, he knows that he's only going to be on A and B phases right here. So he's going to connect A and B over there, and he does have open. And that's something to just be aware of when you're looking at the test switch. Notice he's done this so many times, he looks and sees, well, I'm not even connected on that phase. So he knows I'm not going to connect to that phase. And actually, he's going to show you a trick in a second where he can use that extra alligator clip on the voltage to help him on some strain relief. So, okay.
So I'll go ahead and put these duckbills in. You can see we've got a little bit of corrosion on these test switches. So when you got a little bit of corrosion, it's always a good idea that when you put them in, just kind of work them back and forth a little bit, kind of clear any of that off, make sure you've got a real good connection, you're not missing any of the secondary current.
Nice. And he always opens the shunt blade first, and then he opens up the return blade, which is the long stroke blade, which is where you insert the duckbill. You always open the shunt first, and then you insert the duckbill into the return blade that has that cross-looking figure right there where that duckbill is going to fit in, because we have a vertical piece as well as a horizontal on our duckbills, so it looks like a little cross pattern right there, and that's where he's going to insert the duckbill. And just like he said, that's just from being a pro and doing it enough. Save yourself the time of not having a good connection and getting some funky testing going on. Go ahead and work it just a little bit and coin that surface. Okay.
And try to remember that once you get your duckbill in, go ahead and close that shunt back up. A lot of guys that are new to it, they'll leave them open, put the duckbills in, then they'll go on to their voltages or their next step, and then they'll be trying to start the test, and they're waiting on their pulses, and well, they ain't never going to get any because they've got them shunted. So
right here, I did that.
So hooking up, disconnecting. As soon as I'm done doing whatever I'm doing that needs that shunt, I close it, because the last thing I want to do is leave one open when I take off to head to the next one.
That's right. And also, when I ran that the very first time I did it with no training, I did it and it told me low secondary current input. And I said, oh, what does that mean? And of course, my vectors are bouncing around. And then I looked it back over and went, oh man, as soon as I closed them in, oh yeah, it liked it then, the vectors went solid, and I didn't have that low secondary current input message there telling me an error, so cool.
So hooking up the voltages, I always start with the ground. We've got a ground lug back here in the back. It's kind of hard to get to, but
perfect.
If you kind of stand on one foot and pat your head, you can get back there. And
that's right.
Kind of like with the duckbills, you saw, kind of wiggled it a little bit. They've got a little bit of corrosion on them. And I'll go from ground. I'm going to go ahead and hook up my neutral.
For safety, notice and we saw that the same way with Brown, you always hook your ground and your neutral up first. In case anything comes off, we still are safety there and connected into our ground or our neutral, so we have a path for ourselves.
Get that on that blade, give it a wiggle.
Perfect.
I'm going to go to my A phase. Same thing there. Now I'm not using C, I'm going to use my B phase, yellow there. And if I can get some braids going on with all these wires here. So now I've got those hooked up. And the thing, particularly on the 7 series, you've got this big bundle of cables. Now if you didn't have the table set up, you were farther down, you're going to have more weight holding your wires. So one good thing is if you've got it set up like this where you're not using one of the voltage leads, you can always bring it up here, hook it on that can, and you've got a strain relief.
Nice.
So all the weight's hanging on that C phase that we're not using, and you've got some good slack right there.
Nice. Great field tip there, right? Using that as strain relief. You'll even see some guys that'll make themselves a little metal hook and put it around that cable, and they'll hook it on the can. But either way, just to what he's saying, especially if you're on the ground, that heavy cable's pulling. I just got those little bitty alligator clips, those little bitty teeth. It's very easy. You're sitting there fighting them, and every time you get them connected, you get the second and third phase on it, pulls off the other one. It's just a pain in the neck. So that's a great field tip right there, is to go ahead and use that as strain relief.
So I already have my sight loaded in there. I selected a 5S meter one phase 3-wire on the service top, so no, it's a single phase setup. And the first thing I always do is I go ahead and check my vectors. Primarily at this point, the first thing I look for is secondary current. I want to make sure I've got a 1/2 amp or above to make sure I can get good tests on the meter and the CTs. That half amp secondary translates into 10% of your nameplate. So we know we've got at least 20 amps on those 200 to 5. So we got enough current to get a good test. And also here I can check to see if I've got anything wired backwards or any potential issues before I even get into the test. Because most of the time at this point, if I see something backwards, I'm thinking, well, I'm the dummy, what have I done wrong? And I check here, I'll check the transformer, make sure I haven't done something wrong before I'd say, well, somebody else did it, because Lord knows that I'm not perfect.
That's right. So notice something right there is really important. We've talked about it before, that Bryland mark or whatever we want to call it. Maybe he got that from his boss here, but it's at 0.5 amps, but it also translates to, he even worked it out on the math side, that's 20 amps on 200 to 5s, which is what, whenever you're going to test CTs, we talk about you need to be at least 10% of the rating of that CT for a good ANSI test per ANSI. So there's even more to it than just knowing that if I don't have at least 0.5 amps, it's going to be tough to test it. There's a little math behind it too, so we're looking for 0.5. Now, while you're still at this point right here, do you toggle and take a look, we talk about it in there, and take a look at the primary, so you can just check the primary current real quick to make sure there's no problems on the primary? So while you have it here, we can look at the primary current, and what we don't want to see is some big change in the vectors between primary and secondary, right? Because that is where you will find where someone has a primary CT in there backwards. Okay, if they had to have that in backwards, when you look at primary versus secondary, you'll see that. But remember, we've talked about it in the webinars back in Knoxville, the secondary always follows the primary. So if the primary is wrong, the secondary will be wrong, but you could run a CT ratio test on there and it'll just test them just fine. So it allows us just, let's make sure there's not a problem on that primary side. So before he goes into the test, that button to toggle between primary and secondary current is available. And in this case, since it's a pad mount, Jonathan's got his flexes on there. We're looking at the primary current, right? If you're using a high volt probe for overhead stuff, unless you had the high volt probe up there on it, you couldn't see the primary amps. Okay? Cool.
Now, one thing to notice when you're looking at this, we had right around a 1/2 amp secondary current. We know that's going to be 20 amps. Now, I don't know how well you can see it on the camera. We're showing 47 and 45. Well, why is that? We've double wrapped our flex rings.
Nice.
So we're showing double the current.
Nice.
So if you do have it double wrapped, don't be surprised to see double of what you'd be expecting.
Great
now,
point.
On this setup where we've got two separate services in there, you can look at your secondary current and we're, like I said, right around a 1/2 amp, we should have 20 amps primary on it. Well, in this case, we've got about 40.
Nice.
Now, if it was a big hot mess in there and you don't know if you've got all the right wires in it, if you bring this up and you see the 1/2 amp secondary toggle over to primary and you see, we'd be expecting about 40 amps. If you see 75 amps, you might want to go take a look at your flex rings because you might have grabbed a wire from that other service.
Great point there. I hope y'all caught that. That was a great point if you think about it right there. So we talk about toggling to the primary and taking a look at the primary. Now, to what I said, you got to have the primary sensors on there, right? I got to have I got to have either a high volt probe up there. I got to have 3 flexes on there. But if I can read my primary current and take a look at it, I can also use it. There's another troubleshooting. If I happen to accidentally grab something extra with my flexes, right? When I toggle over and look at my primary current, it's going to be higher than it should be. If I have if they're 200 to 5 CTs and I got a half, and I've got a 1/2 amp of secondary, what would I expect to have on the primary? It's 1/10. I'd expect 20, right, on my primary. If I look just like he said and I see 40 something, then I should go, oh, wait a minute, but wait, I got them double wrapped, so I'm cool with that. If I don't have them double wrapped, and that's not the answer, and all of a sudden I've got this jump in my primary, then maybe I've grabbed something extra in there, okay? Thanks, JP. If you get up in there, and sometimes you've seen them, you open these pad mounts up and it's just, and he got up in there and he grabbed something extra, and he wasn't double wrapped. He knew what he was expecting. Now remember, if you're double wrapped, just expect twice as much. But in your head, that's a great field tip. is you're thinking about how much you expect to see. If I see a lot more than that, if right now he saw 70 something amps, you go, wait a minute, I'll probably grab something extra on it, and I don't have just what I need to test this. Because remember, we made the point earlier, when he got in there and wrapped his flexes around there, you just want to grab what's going through that CT, because I'm testing that CT. Perfect.
All right, everything looks good on the vectors. So we'll just go back, we'll go ahead and go into integrated site test. Now remember, I've double wrapped. So I'm going to scroll on down here. Make sure I check double wrap, or our CT ratios are going to be double what they say.
Perfect.
And we'll go ahead and hit next. And we got one last thing to do. Well, two actually. You remember earlier, John said on these Landis and Gear meters, you've got to pull that voltage off of them to blink them so they start pulsing. Haven't done that yet since we were explaining things, but since we're about to start the test, I will go ahead and pull it if I can get my glove in there. See, the screen went black. Just takes a second for it. Throw it back in, wait on it to boot back up. And I will take my IR pickup.
So now, because he opened that up, right, we said on these Landis and Gears we're testing, it's not all meters, but with Landis and Gears, you just know that now he's going to start getting pulses emitted out of here. Before he did that, we could have sat here all day and wouldn't have got any pulses. Okay, cool.
So here again, we can just double check our vectors, make sure nothing's changed. We've still got plenty of load on it. We've got a little bit more. We're closer to about 6/10. Voltage around 215. Power factor looks real good, 0.99. You're happy about that?
Ooh, 0.99, son.
Go ahead and go to continue.
So as always, we're looking for the large green ball to light up. We'll get a tone, and then start test will pop up. But until it does its checks, you won't see that. But as soon as we get a good pulse here, you'll see start test over here. So you heard the blip, bloop, whatever you want to call it. And when we got that, now we can go start test. And here's where it is going to compare what it measures to what the count and the meter reads that he entered in there on this site. So what he entered in there off of his K sub T, that's saying how many amps it sees every time that pulses. Well, we're going to actually measure voltage times current times power factor and get those watts, and we're going to divide by that number, and we're going to say, well, actually what we measured, we should see, let's say 2.999 pulses, whereas we counted 3. The comparison of those numbers is a true customer load test, because it's taking into account what's going on here. The voltage times the current times the power factor is real load, it's not a phantom load. Okay, so what are we seeing here? We're seeing 132% registration. So now, we obviously know that's not good. I've gotten my second pulse. I'll get my third one here in a second, and it's going to maintain at 132. So I got 132% registration on a customer load test. So some of the things in that Rolodex that are going on right now. Well, for me, one of them is I noticed a third. You know, it's about a third, right? So if it's about a third off, I wonder if they've, because this has happened to me before, and I'll mention it here in a second. I've been out there in the field, and I know what it says on the nameplate of that, faceplate of that meter. It says right there 1.8 or 1.2 for the K sub T. But you can program that meter for whatever you want. And I've actually been out there testing before, and something just like this has happened to me, and I've noticed a percentage that seemed a number, and I asked them, I said, what do you guys have these things programmed for? And they had some 9s that were programmed 1.2. So I was doing the math in my head, and I went, that comes off about it. So sure enough, when they checked into it, yeah, they hadn't programmed them at 1.8. So that could be it. It could also be something with either the connections or something else going on, okay? And if a minute ago when we were looking at the vectors, if you'd noticed on the vectors, and this is going to be funny because we're going to pop over here in just a second and look at something from, it's weird for me to say it today because it's still today, but for y'all it'll be last week. So what you saw last week with Steve, you remember that he was talking about that network on that 5. You remember? You remember right over here when Steve was talking about the difference in that network and that you could be off if you didn't have it selected as a network in there? That's why it is so important that you choose the correct service type. Okay, if you don't pick the correct service type or hang your phone up before you start a webinar, then you could have problems. So what you do is you pick the right one. So if you pick the network, because you got 2 voltages and 2 currents, right? And if you notice, we've gone past here, but when he got ready to start testing, I noticed that he didn't have 2 voltages and 2 currents on his. It was hard to see because of the lighting, but that was something that had perked me up, and I was going, something doesn't look right on that vector. And then sure enough, you're going to see that it's weird. What Steve had talked about actually comes out to fruition right here in just a second. Did you put in 1.2 or 1.8? So you can see where I'm thinking, right? I've already got the stuff's going in my head, and you heard me say to him, did you put in 1.2 or 1.8? Because they went off a third, so that I could have seen that, right? So so what we're going to do is on the next one, we're going to get to the bottom of why we got the 132, and then we're going to go ahead and we're going to test the CTs as well. But so we got a little bit of a mystery going on right now. We know there's something wrong, 132%, it's not going to work. So we got to figure out what the problem is, okay? And you'll see on the next one that we get to the bottom of it. But I just thought it was pretty interesting, this thread that's running through here from the very first one of these, part 1, where we had Steve talk about that, and he brought that up, the whole 5S network situation, and then it came to it because it wasn't chosen correctly. This is what happened. So you'll get to see what in the next one. But listen, it's like I said, it's a little bit weird. I'm talking ahead in time to you, but here in just a second, we'll go ahead and do the third part. So we'll have it ready for you while I'm at the Auburn Meter School. And so we just, again, appreciate the support, appreciate all the feedback that we get. Thank you so much for the comments and stuff that y'all have given Jarrett and Chris at the meter schools. You guys have come up and had some great things to say about this stuff. Really appreciate it because those guys do a lot of work behind the scenes. And I just stand up here and run my gum. So thank you so much for those comments. I do pass them along, by the way, to Chris and JP. So looks like we will go ahead and get set back up again, and we'll get this third one knocked out in this 5S. But please, if you're going to meter school, be careful, okay? Be careful traveling to and from, all right? God bless. Be safe out there.